For our final example, example 13, we now have a table of values at some, specifically chosen x values for f of x and f prime of x, g of x, and g prime of x. We don't have explicit functions anymore, and we're going to do the same kind of thing that we did over here with the graphs. Okay, differentiable functions f and g are defined for all real numbers x. Selected values of f prime, g, and g prime are given in the table, right? So we can see that we have the function values and the derivative values for both of these functions at -1 and +1. So in part A, we want to find the derivative with respect to x, of the product of f of x and g of x, such that x is equal to 1. So we're going to take the derivative, plug 1 in it. And then on part B, derivative with respect to x of the quotient f of x divided by g of x, such that x is equal to -1. And then I'm going to give you a bonus one, a follow-up one. Okay, does this kind of thing actually happen on the AP exam? You bet. They definitely do. So just like I did in the previous video, the previous exercise, I'm going to do this the same way, as in I'm going to take the derivative first, and then I'll plug in our x value, in this case 1. So the derivative with respect to x of f of x times g of x. I have to use the product rule on this one. Derivative of the first times the second. So times the second one, which is g of x, plus the first one times the derivative of the second one. Okay, now everywhere that there is an x, we are going to plug in +1. All right, so technically what this would be is such that x is equal to 1. And now everywhere there is an x, we're going to fill in a 1. Okay, and I'll just get these values straight from the table. It should be extraordinarily easy. Okay, so f prime of 1, and it looks like we're just on the bottom row here. So f prime of 1 is a -3. G of 1 is a -1. Plus f of 1. F of 1 is a +3. And g prime of 1 is a 2. And now we just do some arithmetic here. +3 plus 6 gives me a slope of 9. And there you have it. It's done. It's easy. All right, let's do the same thing for the quotient. So the derivative with respect to x of f of x divided by g of x. Okay, and you know what? I'm just going to leave a little bit of space because I'm going to do that little such that thing that I did before. Okay, so let's apply the quotient rule to this. Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay, and then maybe change colors such that x is equal to -1. Get rid of all these x's here. Oh man, I got rid of my parenthesis. That's okay. Okay, and then put in a -1 this time. So it looks like in this particular example, we are now just using the top row here. All right, so I'm gonna have to keep doing this. Is that making you dizzy? Sorry. Equals, let's see, f prime of -1. F prime of -1 is a 5. And then g of -1. G of -1 is a 3. Minus f of -1 is 6. G prime of -1, -2. Over g of -1, which we already found. It's the 3 squared. Okay, and then just clean this thing up. 15 plus 12 over 9, right? And that gives us a 27 over 9, which is 3. All right, I'm going to give you a follow-up one, a bonus one. We're going to call this number asterisk. And it is, let's let h of x equal to, where are we? Let's see. I'm going to make this the square root of x times g of x. Okay? All right, this is our bonus one. Why don't you go ahead and pause the video and see if you can do it. Now, you may need to pause it so that you can see what the table of values is. It's right up there. All right, did you get it? Well, let's see here. Let's check our work. Let's first find the derivative of this thing, and I will have to use, of course, the product rule right here. H prime of x is equal to, and I'll rewrite this as x to the 1/2 power. And so taking its derivative should be x to the, well, no, leapfrog, 1/2 x to the negative 1/2 power times g of x. Derivative of the first times the second one, minus the first one, x to the 1/2, times the derivative of the second one, which is g prime of x, over, wait, this is, oh my god, are you kidding me? I just got my quotient rule and my product rule mixed up. But you know what? It's almost the same. All I got to do is come over here and fix it with a plus sign. All right, then. Now, what I do want to do before I actually plug any numbers in here is to clean up this thing with some fancy factoring, as we've done before. It happens pretty frequently on these quotient and product rule things. Okay, so I'm going to take out the 1/2 so I don't have a complex fraction, and I'm going to take out the x to the negative 1/2 because it's the lowest power. So 1/2 x to the negative 1/2 power, open up some brackets, and then obviously the first term is just going to be g of x because I took out everything that's in front of the g of x function. So g of x plus, and then if this was a 1 here, 1 divided by half is the same thing as 1 times 2, so it's 2. X to the 1/2 divided by x to the negative 1/2. You subtract your exponents, 1/2 minus the negative half is to the first, so x, and then times g prime of x. And then maybe rewrite it with a positive exponent, and we have h prime of x being equal to, that 2 is going to go on the bottom, the square root of x is going to go on the bottom, and I have g of x plus 2x g prime of x, all of this over 2 times the square root of x. Okay, there we go. We have the derivative, and now what we're going to do is evaluate this specifically at 1. Let's do this at 1. So maybe what I do is I get out my eraser. Everywhere there's an x, I'm going to stick in the number 1. And I have to do, like I'm bound by the table. I mean, I can only do positive 1 or negative 1, so I'm just going to go ahead and do 1, 1. This one was a 1, also 1, and 1. And then just simplify. Okay, so g of 1 I'm going to get from the table, and g prime of 1 I'll get from the table. This is the bottom row. G of 1 is negative 1, g prime of 1 is 2. So I have a negative 1 plus 2 times the 2 that was in the table over 2 times square root of 1 is 1, which is 4 minus 1 is a 3 over a 2. And now you have it. All right, let's kind of summarize this lesson just a little bit here with, here are all the differentiation rules that we've learned so far. So we have the constant rule, so the derivative with respect to x of some sort of constant is 0. We have the constant multiple rule, so when we take the derivative of a constant times a function, the constant just comes along for the ride. If I have, this one is the product rule, which was part of this lesson. The derivative of product is, notice how they wrote it. I don't like this, right? Because we like to write it in the other direction. Twins dating twins, derivative of the first times the second one, plus the first one times the derivative of the second one. Because when I think of it like that, it's also going to make the quotient rule that much easier to remember. The derivative of the top times the bottom minus the top times the derivative of the bottom squared. We also have the power rule here where we're doing some leapfrogging. N times x to the n minus 1. The derivative of a sum is the sum of the two derivatives. Same thing with the difference. And then we also have the derivative with respect to x of e to the x is just e to the x. So we're starting to build this large collection of differentiation rules. And we're going to get some more of them in the next lesson, and I do believe the next one is about trig. All right, so here's recap. Derive and use the product rule and the quotient rules. Done.